So now we're going to start talking about flight theory, basically lift and drag. And before we start talking about lift and drag, I just wanted to define a few terms. I'm an aerospace guy, so if I'm going to throw these terms out, I want to make sure that you guys know what I'm talking about. So typically when we're looking, and I'll reference this all to flight, but this all completely applies to underwater vehicles too. So submarine will have the same thing. And since we don't deal with an X, Y, and Z axis in any of this, we deal with pitch, roll, yaw. And that's because these coordinate systems are movable. So, and it'll always be tracking the vehicle that's moving as the center of the coordinate system. So the first thing we have is everything's going to be based off of the direction of the travel, whether it's the direction of flight, direction of being underwater. So the longitudinal axis will be that axis that's along the path that you're going. And so if you spin around this axis, this is called the roll axis. And so you have a moment, or we'll refer to rolling moments and rolling axes. So 90 degrees to that would be what we call the pitch axis. And so you'd pitch, and this would be nosing up and nosing down of your plane or your submarine. And the last thing is the yaw axis, and the yaw axis spins kind of in plane around things. Now, obviously, this is not a flight dynamics class. We won't go over that. But, you know, just in case you're wondering, the rolling axis would be controlled by these surfaces here on the wings called the ailerons. The pitching by these surfaces in the tail called the elevators. And then the yawing is taking place of this guy right here, the rudder. And it's called the rudder. It works just like the same as a rudder in a boat. See, boats and planes overlap. So this flight is a maritime subject. So typically what we'll end up doing, though, is because we'll say we have symmetry and we'll look at things from the side. And so for a lot of simplified analysis, especially what we're going to be doing, everything's going to reduce down to that lift and drag axis. And then we'll be worried about one thing, and that will be the pitching moment. And so typically that's the simplified way that we'll look at flight stuff. And for what we're doing in this class, that's really what we're going to get down to, is we'll get down to those two forces and the moment. Let's talk about a couple things about a wing. So this is an airfoil, kind of in 3-dimension, and there's just a couple pieces of terminology that we need. And the first is the leading edge, which is the first thing to hit the fluid. The trailing edge, which is the last one to leave the fluid. Now those two are important because there is a line that connects the two of them that we call the chord line. And so the chord line is basically kind of the width, the depth of the wing. And chord is spelled C-O-R-D. Actually, there's an H in there, C-H-O-R-D. And so the chord line will be referred to as C. And so that will come up later in our discussions. And then one thing that's not listed on this picture is the distance from wingtip to wingtip. You will hear that called the wingspan. But it's typically just referred to as the span. And the span is denoted as B. And so that gives us our chord length, our span. That gives us kind of the geometric progression properties of an airfoil. And so let's take a look at drag. And as I see that I flipped over to the slide, I've got a different thing prepared for drag, so we'll start a new lecture there.